Hello all, today we are going to be covering 4.6, completing the square. This is just another way to solve quadratic equations. We've also used factoring as well as the quadratic formula. Like the quadratic formula, completing the square can be used all the time. That's different than factoring when that can only be used in some cases. So your objective today is you guys can solve equations by completing the square, and students can rewrite functions by completing the square. So we're going to solve these quadratics. I have the steps written off to the side here. We'll go through them. The first step is we always need to rewrite the equation for completing the square in ax squared plus bx equals c form. So this is different than our quadratic where we want it in the form we have right now, ax squared plus bx plus c equals 0. We want this in the form ax squared plus bx equals c, okay? So we then have x squared minus 12x equals negative 4. Then we can go ahead and do our next step since we finished that one. This one we can actually skip because we already have a 1 value for our a. If it was a different number out front, that would change it, but dividing all terms by a, in this case 1, would not change anything. So we'll go ahead and go to step 3. Complete the square by adding b over 2 squared. So this guy, step 2, we don't do anything. To complete the square, we are going to take b over 2 squared. So our value of b is negative 12. So negative 12 over 2 squared is equal to negative 6 squared, which then equals 36. And then you'll notice here it says add that to both sides of the equation. So I am going to add 36 to both sides. So we have x squared minus 12x plus 36 equals negative 4 plus 36. Now, step 4, we might actually have covered it up a little bit. We are going to factor the trinomial. So let me shrink some of this down so it all fits where it's supposed to. So we'll shrink that. All right, and then we'll also reveal step 5. We're going to find square roots, okay? So, factor the trinomial. You'll notice now over here on the left side, we have the trinomial. We are going to factor it. And it happens the way that we came up with this. Oops, not 42, 32. We can take 36. It's a perfect square. We're going to take the perfect square of those and then just decide which sign we want. It also happens to be this guy up here. That's just the way we set it up. And we take the square root of 36. We get those numbers. We also then know that these are repeated, so we can write this like x minus 2 squared equals 32. Now, step 5, we already revealed, says find the square roots. So we'll find the square roots. X minus 6 equals the square root of 32. Step 6, we're going to solve for x. So we add x on both sides. Now notice this is x equals 6 plus or minus root 32. Step 7 is check for reducing. That's kind of not a very good English way to put it, but if our square root reduces, which this one does, square root of 32 can have a square root of 16 pulled out of it. We can reduce. This is actually equivalent to square root of 32. So our final answer is x equals 6 plus or minus 4 root 2. If we had solved by the quadratic equation, it would be the same solution there. So we'll go ahead and follow these same steps for the next problem. It just looks a little different. Also, there's a typo here. Go ahead and erase that. That should just be a 0, not a 0v typo. So if you recall step 1, we go ahead and add 4 to both sides. We have negative 2x squared plus 4x equals 4. Then we skipped step 2 the last time, but because the a term is now a negative 2, we divide all terms by negative 2. And we get x squared equals negative 2, x squared minus 2x equals negative 2. From here, we take our b over 2 squared, plug in b, this time it's negative 2, so negative 2 over 2 squared equals negative 1 squared, which equals 1. Now we add that b over 2 squared term to both sides, so x squared minus 2x plus 1 equals negative 2 plus 1. We have to add it to both sides. This is kind of a thing that we do in math sometimes called adding 0, 0, and quotation marks, because if we were to subtract 1 on either side, it wouldn't change anything about the equation, but it helps us to solve it. Now we know, because this is a completing the square equation, we just need to take the square of 1, or the square root of 1, I should say. That is just 1. Check your signs. They're both going to be negative again. Notice, once again, this part up here is what comes down to be inside of our parentheses, our factors. Go ahead and take negative 2 plus 1, and we get minus 1. Finish solving by combining our two factors since they are the same, our repeated factors. Take the square root, and you get x minus 1 equals the square root of negative 1, which if you recall is the same thing as plus or minus I, the imaginary term. Then you add 1 to both sides, and we get x equals 1 plus or minus I. And we're done. So that one had one more extra step too. If you need to, you can pause between each step, try to write them down, follow along. We will also do this last one. Same thing, once again, you want to get the c term on the side by itself, so I'm going to subtract 9 on both sides. We need to then divide by 4. Notice we will get decimals. That is okay. They're just a little more difficult to work with. No big deal though. So we get x squared minus 3x equals negative 2.25. We now want to add the b over 2 squared term to both sides. So this is negative 3 over 2 squared, which is then equal to, well, we can't reduce the negative 3 over 2. That's what we had done before. So this is equal to positive 2.25. We add that to both sides. What do you know? On the right side, we get something pretty nice. The 2.25s cancel out, so that's nifty. So we are then left with equals 0, and we need to factor over here. Now, don't forget the trick that we saw every other problem that we've done so far. So far, this guy has been what we break down out here. I'm going to rewrite that negative 1 over 3 as negative 1.5, because that's equivalent to 1.5, and then we're going to check it real quick. So I know if we take the negative 1.5 plus the negative 1.5, those should equal my b term, negative 3. They do. So that, so far, so good. Then if I take those two multiplied, they should equal 2.25. That is the case, so we are good to call those our factors. That is also the square root of 2.25. You can check me on that, but it is. We wanted to take the square root of that because we are completing the square, so we are good to go. Notice these are once again repeated terms. It's another part of completing the square that we get. We take the square root, and we have x minus 1.5 equals 0. We add 1.5 to both sides, and we get one solution. So notice if we had done our discriminant step, we would have gotten that we would get a 0 in the discriminant and one real solution. While this problem over here, we would have gotten a negative number in the discriminant and said no real solutions, but imaginary solutions. And this one would have given us a positive in the discriminant, so 2 real solutions. This one we actually probably could have factored. We didn't. That's fine. Like I said, completing the square works in every case. So go ahead, take some time, try some of these on your own. There is a Math Excel, and have a great afternoon.